Welcome students to the computer science class. In this tutorial, we will learn about the different types of random access memory. In the previous tutorial, we have learned about the types of memory, that is the primary memory and the secondary memory. Now we will see the types of RAM that are used in a computer system. There are two kinds of primary memory we have seen, that is the RAM and the ROM, random access memory, and read-only memory. So we will see about them. We will discuss about them in this tutorial. So what is a random access memory? It is the main memory. It is a temporary memory of the computer that is used as the workspace, temporary workspace, or a scratch pad of the processor. The processor works on the data that are present on the RAM. It should be present on the RAM, otherwise it cannot work on those data. So what is RAM? The RAM consists of the memory chips that can be read from and written to by the processor and other devices. The processor can read the data and instructions from the RAM. It can also write to the RAM. After it has already processed the data, it has already executed the instructions, it returns back the data, it writes the data back on the RAM. When you turn on a computer, certain operating system files are loaded into RAM from a storage device such as a hard disk. The operating system is there on the hard disk. So, to make the computer ready, the operating system gives a platform for the other application software to run. It coordinates with all the devices, the input devices and output devices that are connected to the computer system. So the operating system gets loaded on the RAM from the storage device, that is hard disk or a flash drive or a CD-ROM drive. So it gets loaded from a secondary storage to the primary storage. The files remain in the RAM as long as the computer is on. The file remain in the RAM as long as the computer is on. When additional applications and data are requested, they are also loaded into the RAM from the storage device. So the operating system is loaded. Now the computer is ready to run your application softwares, to execute the instructions you give. So as soon as you give some instruction, you try to run an application program, it gets loaded on the RAM. It fetches the data from this hard drive to the RAM. Then it executes on the processor. The processor interprets and executes a program on application's instructions while the program or application is in RAM. So whatever the instructions there in the program, it is executing from the RAM. The program is on the RAM and it is getting executed by the processor. During this time, the contents of RAM may change. RAM can accommodate multiple programs and applications simultaneously. For example, after the operating system gets loaded on the RAM, you are trying to write a letter on a word processing software. You open your Word and you start typing a letter. While typing, you also want to listen to music that are there on the hard drive of your computer. So you also turn on the MP3 player. So both the Word file and the MP3 player gets loaded on the RAM. The Word file, the Word program, along with the file you are creating, is there on the RAM. The MP3 program, along with the MP3 file, is also there on the RAM. So in this way, all the data you are currently executing, you are getting the output from the applications, whatever applications you may be using. You may be using a browser software. You may be browsing the internet. So whatever the applications you are using are there on the RAM. It gets loaded on the RAM from the storage device, and then only the processor can interpret and execute the program, the application's instructions, while the processor or application is in RAM. During this time, the contents of RAM may change. So it is executing. The processor is executing the data. So this data will get changed. It will be processed. Naturally, it will be processed. You are writing a letter on the Word file. So you are making a change in the file. The file was initially blank. The file may initially contain some text already. You are making some changes, or it may be blank. You are making some. You are writing something. You are making some changes. So the contents in the RAM are getting changed. So RAM can accommodate this, and it can also accommodate multiple programs on it. I hope it is clear to you. Still, if you have got any problem in this particular point, you write your comments. Ask your doubts in the comment section. I will make further tutorial on this. So RAM is accommodating the files and programs that are currently running on your processor, on the computer's processor. RAM is a volatile memory and it loses the contents when the computer is turned off. For this reason, you must save the items you may need in the future. Saving is the process of copying items from RAM to the hard disk. So the contents in the RAM got changed. Now it is there on the RAM. So if you want that change data in the future, you have to copy that item to the permanent memory or the secondary memory of the computer. So this process is called saving. How program instructions transfer in and out of RAM. Right now what I have told is about the instructions getting loaded in and out of RAM. Once you are trying to load some software it is getting transferred from the hard disk of the computer to the RAM. Once it is done, you are closing the application, it is just removed from the RAM. Similarly, when you are turning on the computer, the operating system gets loaded on the RAM from the hard disk. Once you are turning the computer off, you are shutting the computer down. You are shutting down the computer. The RAM loses all its contents. Whatever it has loaded, whatever the system files, operating system files it had loaded for while booting, it will simply remove from the RAM chip. So how program instructions transfer in and out of RAM? When you start the computer, certain operating system files are loaded into RAM from hard disks. The operating system displays the user interface on the screen. So, what is the user interface? It is the graphical user interface. You can give instructions by means of the graphics. You can see the icons, you can see various symbols, and you can click on them to give instructions to the computer. Giving instructions, you are executing the instructions on the processor of the computer. See, the operating system displays the user interface on the screen. What is the user interface? You can see on the user interface the loaded software, the installed software, not the loaded ones but the installed ones. Once you load it, it starts running. Loading means loading from the hard disk to the RAM. So whatever application programs are installed on the hard disk are shown on the interface of the operating system. When you run a browser, suppose a browser is installed on your hard disk, you can see the browser icon on the desktop. So you are running, suppose you are running it, you have clicked and it starts running. The application's instructions are loaded. The files, the browser application, the files of the browser application gets loaded on the RAM and the hard disk. The browser and certain operating system instructions are in RAM. So operating system files were already there in the RAM. Now the browsers are also added to the contents of the RAM. The browser window appears on the screen. When you run MS Paint program, suppose you want to draw something, you have clicked on MS Paint program. Now what will happen? The program's instructions gets loaded in the RAM from the hard disk. The Paint program along with the browser and certain other system instructions are in the RAM. So system instructions were already there. Along with that, Paint program got loaded on the RAM. The Paint program window now appears on the screen. Now as soon as it get loaded on the RAM, what will happen? You can see the Paint program on the screen. So that is how it works. Once the software starts running, the application program starts running, you can see it on the screen. When you exit an application such as the browser, its instructions are removed from the RAM. Suppose if I click on this close, what will happen? It will be simply removed from the RAM. Right now I am doing my work, I am reading PDF file through this PDF reader. So this PDF reader is on the RAM chip of my computer. So if I close it, it will be removed from the RAM chip. So when I exit the application, such as the browser, its instructions are removed from the RAM. The browser no longer is displayed on the screen. So you can be using the browser, you can be using Paint, you can be using your MP3 player, whatever program you are using, it is getting loaded on the RAM and you can use it accordingly. So unless and until it gets loaded, it is on the hard disk and it is not executing. Once it starts executing, it must be on the RAM. The files are on the RAM. Okay. Now that is how the things are working. Once you loading it, it comes to the RAM. Once you close it, it gets removed from the RAM. Next, types of RAM. There are three common types of RAM chips: dynamic, static, and magnetoresistive RAM. Dynamic RAM or DRAM is inexpensive and most popular type of main memory used in computers. Many variants of DRAM chip exist, most of which are faster than the basic DRAM. Synchronous DRAM is a faster and more reliable dynamic random access memory. DDR synchronous dynamic RAM. Double data rate synchronous dynamic RAM is faster than SDRAM. That is, it transfers data at twice the rate. Transfer data twice instead of once for each clock cycle. DDR2 is second generation DDR with faster speed than DDR. Again, DDR3 third generation double data rate, which is designed for computers with multi-core processors. Computers having more than one core. For them, the third generation double data rate RAMs are used. DDR4 fourth generation, even faster than DDR3. So as the technology evolved, as the kind of RAM technology grew, it developed, they become faster and faster. Rambus DRAM, Rambus Dynamic RAM, faster than SDRAM, Synchronous Dynamic RAM. Static RAM or SRAM is efficient and fast, but is very expensive. SRAM or static RAM is used in small amount as cache memory in a computer. Cache memory improves the performance of a computer by storing the data which the computer frequently uses. So static RAM is efficient, it is fast and very expensive. So it is used in small amounts and it improves the performance of a computer by storing data which the computer frequently uses. So all the data that are frequently used by the processor are there on the cache memory of the computer. So what happens if the data it is frequently using is not properly accommodated on the cache? The data that are frequently being used are are occupying more space than the system cache. It may so happen that the cache is not sufficient enough. Then the system gets slower. It will not perform at a fast rate. You will find that the application program that is running at a slow rate, at a slow speed. So that is why we see that the system is working slow. Next is magnetoresistive RAM or MRAM, a newer type of RAM which stores data using magnetic charges instead of electrical charges. So it uses the magnetic charges instead of electrical charges in the magnetoresistive RAM. Its manufacturers claim that MRAM has greater speed and storage capacity. MRAM has greater storage capacity and consumes less power and has faster access time than other RAMs. So it accesses data at a faster rate than other RAMs. Also, MRAM retains its contents after the computer is switched off. That is something very advantageous. It retains its contents after the computer is switched off, which could prevent the loss of data for users. So these are the different RAMs. Now the memory module. You can see this is called a RAM chip, and different kind of RAM chips are used in a computer. 72 pin RAM chip, 168 pin RAM chip. So these are used in various computers having various requirements. Now what is a memory module? It's a memory module is a circuit board that holds the memory chips. RAM is a type of memory chip that makes up the main memory in many computer systems. So the memory module is the circuit board that is holding the memory chips. Two types of memory modules are single inline memory module and dual inline memory module. In the single inline memory module, there are 30 or 72 pins, but 72 pin module is common. In a dual inline memory module, there are 168 pins. Okay, so you have to know that much from this memory module. Next is the RAM requirements. The amount of RAM on the computer determines the amount of program and the data a computer can handle at one time, which affects the overall performance. A computer can only manipulate data that is in its main memory. More the RAM, faster the computer will respond. So, the amount of RAM on the computer will determine the amount of program and data a computer can handle at a time. So, we have said that we can run multiple programs at a time. But what is the limit? Can I run at a time more 10 programs, 20 programs, or 200 programs? What is the limit? The limit is dependent on the size of RAM, how much it can accommodate, how many data it can store, how many program it can load on it. That is dependent on the size of the RAM, the storage capacity of the RAM, and that will determine the overall system performance. Okay, so more the size of RAM, more the capacity of RAM you are having on your computer system, more is the performance, and faster the computer will respond. Okay, there are more space, so at it can accommodate more data on it, so it will not require the data to be transferred from the hard disk quite often. So all the data that is required to be worked on, to be executed on, are there on the RAM itself. So it will respond very quickly. As there is no transfer from the secondary storage to the primary storage, everything that is required, every instructions that is running, every data that may be required are there on the RAM. So there is no transfer and the program will run faster. The computer will respond at a faster rate. So that is about RAM requirements, the importance of RAM requirements. Next is read-only memory. We have known that RAM is a volatile memory. But what if our primary memory is permanent? What if we need a primary memory in permanent nature? That is, when the power is not there, we need the data to be stored on a primary memory. Obviously, our computer has got a primary memory. Why do we need a primary memory? Have you ever thought that if there is only a temporary one, only RAM is there, and no permanent primary memory is there? If there is no permanent primary memory, that is a kind of memory on which the processor can act, the data on which the processor can function, is a primary memory. And what if there is no permanent kind of primary memory? Can it work? No. The primary memory of our computer is having the BIOS written in it. That is the basic input output system, from which it is getting an instruction from where to load the operating system, how to load the operating system, and where is the operating system. So these basic things should be available to the processor. These instructions should be available to the processor so that it can load the operating system from the hard disk to the RAM when you are turning on your computer. You are putting on the power, and from where is it getting instruction to load the operating system? Who is giving instruction to load the operating system? Because you cannot give instruction to load the operating system, because you can give instruction to the operating system after it is loaded. The operating system gives you the interface on which you can give instruction. But what if the operating system is not yet loaded? Where are you giving instructions? We are not giving instructions when the operating system is loaded. It is getting loaded from the BIOS by reading the instructions, by executing the instructions written in BIOS. That is the primary memory and the permanent memory of the computer. In the ROM chip, BIOS is there. It is getting the BIOS, the instructions to load the operating system. So let's see how ROM is efficiently giving and serving different memory devices on various kind of electronic goods. We have already seen how it is beneficial for the computer in the form of BIOS. It is also helpful in other electronic devices. So let's see. ROM, read-only memory, refers to the memory chip used for storing data that can be read only. You can read only, you cannot write. The data on the ROM cannot be modified, hence the name read-only memory. ROM is non-volatile. Its contents are not lost when computer is switched off. So even when the computer is switched off, the contents are there in the ROM. So that is the magic. That is the point. The computer you are shutting down, still then BIOS is there intact. So that is the point from which you will load the operating system next time. You are turning the computer off. You are turning off the power. There is nothing in the RAM chip. Still it loads the operating system following the instructions in the ROM chip of the computer called BIOS. ROM chips contain data, instructions and information that is recorded permanently. For example, it contains the BIOS, which is a sequence of instructions the computer follows to load the operating system and other files when you first turn on the computer. Many other devices also contain ROM chips. For example, ROM chips in many printers contain data for fonts. Manufacturers of ROM chips often record data, instructions or combination of chips or information on chips when they manufacture them. These ROM chips are also called firmware. So when you turn on the printer or any kind of electronic goods like the washing machine, like the refrigerator, you can see some programmed display. So where from this display coming? How it is working? It is working according the program already written in programs on the ROM chip. The manufacturers has written some programs on the ROM chip of the device. It is executing those instructions on the ROM chip when the power is put on. So that is how it is working. In other electronic goods like the printer or any kind of electronic goods, they are having the ROM chips called firmware. Now some of the variations of ROM chips. ROM chips can also be of three kinds. From programmable read-only memory, which is a blank ROM chip on which you can place items permanently. Programmers use microcode instructions to program ROM chip. erasable programmable prom erasable programmable ROM, that is another type of ROM on which contents are erased by ultraviolet light and then reprogrammed by an RPROM, reprogrammed by RPROM program. Electronically electronically erasable programmable read-only memory, another variation of PROM which allows programmer to erase microcode with an electric signal. So some ROM chips are programmable only once. You can program it only once. Some are erasable and programmable. You can erase the previously written programs and you can write new programs by ultraviolet light. And some are electronically erasable and programmable. So these are the three different variants of the ROM chips, right? The PROM, the EPROM and the EEPROM. These are the three variants. Next we will see about the secondary memory, that is used to store data for a long time. We will do the secondary memory in our next tutorial, because in this one we have discussed enough and we should have a clear idea about all the things we have discussed. Any problem you find up to this before secondary memory, you just comment it and I will try to solve your doubts in my next tutorial. Before we continue, we may solve or I may make some new videos for solving your problems. Okay, so write your comments in the comment section. Thank you all.